Alrighty, good morning everyone. Happy Tuesday. Welcome to our zoo education program. My name is Rachel and today we are going to focus on 5th grade curriculum relating to energy transfer and the food chain. But really, even if you're not in 5th grade, this is a really good lesson. We have a lot of excellent things to cover today. Now, when we talk about energy, the first thing that we need to talk about is what an ecosystem is. Because ecosystems all around the world, from prairies to woodlands, deserts to oceans, they have lots of moving parts in terms of energy. Now, when we're discussing ecosystems, it's not just the plants and animals that live in a given ecosystem, like a prairie. It's also the living and non-living things and how they interact with each other. So in a prairie, the whole ecosystem consists of the plants, the animals, but also things like the sunlight and the soil and the water. So when we're talking about energy today, please keep in mind that it's the interactions between living and non-living components in an ecosystem that make up how a food chain works. So energy, at its very basis, what that means is it's transferring from living to non-living things and vice versa. And it does so in a food chain. So what a food chain is, it's the order in which energy, food, moves from one organism to another through an ecosystem. So here in Kansas, we have lots of different ecosystems. We have prairies, woodlands, wetlands, we have urban areas. But today, I would like to focus on some animals that we have locally here in the Midwest. So, when we are talking about the transfer of energy, when we talk about a food chain, it kind of looks like this in a pyramid form. And there are lots of moving parts to a food chain. We have the sun, we have our plants, we have a variety of animals, and energy is the transfer between differing levels in a food chain. Now, when we talk about food chains, we also want to talk about food webs. In a food chain, this shows how energy moves from one animal to the next in a linear pattern. So from how energy goes from plants to animals to other animals. But in a food web, it shows it a little bit more complex. It shows how food, how energy, does not just move from one plant to another or one animal to another, but how it is very complex. So you guys can see in this example, it's a big web, kind of like a spider web. It shows how plants can be eaten by a variety of different animals. For instance, in this example, the grass is eaten by the grasshopper, the deer, and the prairie dog. The nuts and berries are eaten by the squirrel and the blue jay. The blue jay here is an omnivore. It eats both plants, like the berries and the nuts, as well as other animals, like the grasshopper. Animals on the top here, they can eat lots of things as well. For instance, the squirrel is eaten by the vulture, the coyote, and the mountain lion. So when we're talking about the transfer of energy today, friends, we are going to be talking about it in these two realms. The food chain, which shows one thing eating another, and the food web, which shows a variety of differing food items that animals can eat. So, I keep using that word energy. So let's start from the top. Where does energy come from? Well, my friends, energy can neither be created or destroyed. I can't just say, poof, let's make more energy. Energy is constantly flowing through an ecosystem, and energy starts from the sun. So looking at this food web or food chain here, we can see that the sun is included, and that is because sun produces energy for which organism on here? Do you guys know? What on here does the sun produce energy for? If you answered the grass, you are right. All food chains start with plants. Plants are very, very important because plants are what we call producers. And plants are producers because they produce their own food. And they do it by chemical reactions from the sunlight. This process is called photosynthesis. And what it is it's when plants use the sunlight, water, and carbon dioxide. That chemical reaction occurs in the plants, and those three things turn into glucose, which the plants use for their food, their nutrition and energy, and oxygen, which we as humans use to breathe. So without the sun, plants could not produce their own food. So we need sun for the plants. That is where they get their energy. So the original energy comes from the sun to the plants, who are the bottom of our food chain. You will notice in both of these examples that plants are there. You cannot have any animals if we did not first have plants. So the bottom of our food chain is always going to be our producers, our plants, who produce their own energy from the sun. Well, if plants are producers, that means animals are the opposite. They are what we call consumers, because animals, including humans, consume our food. We do not stand in the sun and use photosynthesis to get our energy. We actually have to eat certain things to produce all of the nutrients that we need to grow. Energy provides us the food that not only allows us to grow, it also allows us to repair our body when we're injured, or to stay warm, or to have babies and survive and meet our needs. So the food that we eat is vital for our own survival. So consumers are animals, organisms, who eat their food, right? Who consume their food. And that could be a herbivore who only eats plants. It could be an omnivore like humans who eats both plant and meat. Or it could be a carnivore who eats meat. But all animals in the world, they are consumers. So when we're looking at a food chain, these animals are organized in differing tiers, differing stages. And the reason that is because this shows how energy is transferred from one organism to a next. So the sun provides the grass with all of the energy it needs to survive, to find the food that it needs. Well, the grass and other plants at the bottom of the food chain here then provides food for the first level of consumer, the herbivores. So on the food chain, this section right here is what we call our primary consumers. Primary just means one, the number one. And primary consumers are going to be our herbivores. They eat the producers. They eat the plants. So in this instance right here, we've got our grasshopper eating the grass. So the primary consumers here are always going to be plant eaters. They're the first level of consumption, the first level of animals who eat their food. So if the grasshopper eats the grass, what do you guys think the Great Plains skink, which is a type of lizard we have in Kansas, what do you think it eats? If you answered the grasshopper, you are correct. So as we move up the food chain, you can see that the lizard eats the grasshopper, which eats the grass. The snake eats the lizard, who eats the grasshopper, who eats the grass. The cougar eats the snake, who eats the lizard, who eats the grasshopper, who eats the grass. So the food chain is showing how energy is transferred from the sun to the plants and from the plants to all of these differing levels of consumers. So the levels of consumers have kind of fun names, and they just refer to the number in which they are consuming. So like I said, primary consumers are always going to be our herbivores, our grasshoppers. Moving up, if primary is number one, the level up is what we call secondary, which means number two. So in this example, a secondary consumer is the lizard who eats the grasshopper. But you guys, secondary consumers are oftentimes omnivores. Secondary consumers, in this example, the lizard ate the grasshopper. But these are not set tiers on the food chain. A lizard could directly eat some vegetables sometimes, or some fruits, and then it moves down to a primary consumer. So oftentimes this layer on the food chain is an omnivore. They could easily eat another animal, or they could switch to eating plants. And if they switch to eating plants, they move from a secondary to a primary because they then switched to directly eating the grass themselves. So if the lizard here ate the grass, it would be on the same level as the grasshopper. But in this image, it is eating the grasshopper, which means it is a level 2, a secondary consumer. Now moving up the food chain, any of our consumers on the top, tertiary, which is number 3, or quaternary, which is number 4, these are always going to be our carnivores, our meat eaters. So in this instance, the snake has eaten the lizard, who has eaten the grasshopper, who has eaten the grass. So the snake is a 3rd level, a tertiary consumer. Now, let's say the lizard ate the grass, right? Then the snake still has to eat the lizard. So these top level are always going to be carnivores, even if they move up or down 1 or 2. Same with the cougar, the mountain lion on the top. Our quaternary consumers are our number 4 consumers. They have eaten something that has eaten another thing, which has eaten another animal, which has eaten a plant. But again, these can move up and down on the food chain just depending on what their food has already eaten. Now you guys, the consumers that are at the top, like our mountain lion or a hawk or an eagle, these are our apex predators, which means they are on the very top of the food chain. Not many other things, or if anything, is able to actually eat them. Now interestingly, the number of animals we have at differing levels in the food chain is different. If you notice in this pyramid, the bottom is bigger than the top. That is because more energy is needed at the bottom of the food chain to sustain enough energy for animals at the top to survive. What I mean by that is we need a lot of plants to make enough food for our herbivores. But herbivores like grasshoppers, many bugs, many small mammals, these animals are food for lots of other things. So herbivores have to have a lot of babies. That is why mice and bugs and animals lower on the food chain have so many babies, is because they have to provide food for other animals, and there needs to be enough of them to sustain enough lizards, and there has to be enough lizards to have enough snakes. So mountain lions, they usually only have 1, 2, 3 cubs at a time, whereas bugs can lay hundreds or even thousands of eggs. So the higher up on the food chain they are, the less babies they have, because we need more energy at the bottom, that's why it's bigger, to sustain smaller numbers of animals at the top. Now, you guys might be noticing that I've got some animals on the side here. These are what we call our scavengers and our decomposers. What a scavenger is it is a large animal that eats dead or decaying materials. So if it is inside the food chain here, inside the pyramid, this is a predator-prey relationship. The mountain lion has hunted and killed a snake. The snake has hunted and killed the lizard, who has hunted and killed the grasshopper. They are actively killing live things. But that doesn't mean that if something dies, its body cannot be used for consumption. Think about how many times people drive on the road and they hit animals like a deer. While that deer has already passed away, it can still be eaten by other animals. So our scavengers are on the side of the food chain over here, because while an opossum is not actively hunting and killing a deer or a snake or a mountain lion, if that animal has died, that opossum or that turkey vulture, our scavengers, will eat them. So scavengers are animals who eat dead things, dead plants and animals, but that energy is still transferred to them. Now, decomposers are going to be our little guys who do the same thing. So in this example, it is going to be things like the millipede and the fungi, like mushrooms. They can help break down dead and decaying plants and animals, but they do so on a microscopic level. So if a deer gets hit by a car, our turkey vulture and our opossum might eat almost all of it, but whatever little bits are left, the bugs and the mushrooms and the other bacteria, they break it down on a microscopic level. So the difference between our scavengers and our decomposers, both eat dead things. One just eats them on a larger scale, the scavengers, whereas the decomposers break them down on a smaller scale. Now you guys, earlier we talked about ecosystems and how living and non-living things interact. Well, I want to come back to that with our scavengers and our decomposers. Because if you look right here, you will notice that these chains do not end with our apex predator. Once we get up to our quaternary, our fourth level consumer, like in this image, the hawk, energy doesn't just stop there. Once the hawk passes away, our scavengers and our decomposers break it down. And not only do they eat it for themselves for energy, but especially the decomposers, the little guys, they break down those dead organisms and they recycle them back into the soil. And the nutrients in the soil then goes back to helping our plants grow. And the whole process starts over again. So the nutrients from the dead things goes into the soil. It helps the plants to grow using the energy from the sun that we talked about. And then when a herbivore comes along and eats the plants, the energy still moves to that herbivore to grow, to reproduce, to stay warm, to repair itself. All of energy is used for those things. So although it is called a food chain, just know that it goes essentially in a circle. All of the energy is constantly being transferred from one organism to the next. Now you guys, what we haven't talked about in this is the fact that humans play a vital role in the food chains and food webs. We are not omitted from ecosystems around the world. We are very much a part of it. If you look at our food web here, there are some things on this that humans may directly eat. Some humans hunt deer, and they use those deer as their food, as one of their primary meat sources. We as humans might eat nuts and berries, right? Some people around the world actually eat bugs. It's a wonderful source of protein. So humans are consumers, but we also play a role in this food chain and these food webs. So remember, we are not separate. We are very much a part of it, both in the good things that we do, as well as the bad things that we do. And we'll talk about that a little bit later. So I want to show you guys 4 examples of animals, and we're going to talk about where they might be on the food chain, just to do a little bit of practice what we've talked about today. So the first animal that I have is a deer. Now deer are herbivores, and as an animal, they are a consumer. So do you think they would be the quaternary, the tertiary, the secondary, or the primary consumer? Remember, they are a herbivore. So which level is a herbivore? It's always going to be our primary consumers, our first level of consumption that directly eats our producers. So herbivores like deer, they would go right here on the food chain. Now an animal that is an omnivore, like a skunk, it depends on what they've eaten. Skunks love to eat insects. They also love to eat berries and other types of fruits and vegetables. So if a skunk has eaten a berry, just like the deer, it is a primary consumer. However, if it has eaten a bug who has eaten a plant, it is moved up to a secondary consumer. So remember, places on the food chain are not set. Depending on what an animal eats, they can move from one layer to the next really easily. A coyote is the same way. These animals are also omnivores. They might be actively hunting and killing a rabbit who was eating grass, which puts them as a secondary consumer. They might have consumed some berries themselves, which puts them as a primary consumer. They also might have eaten a dead animal. Let's say an opossum got hit by a car and a coyote finds it on the side of the road. That then moves them outside of the food chain directly because they're not in a predator-prey relationship, but they are still eating that energy and passing it on. So they then become a scavenger. Final one is our hawk. Hawks are at least going to be a tertiary consumer because they are a carnivore, right? They could eat a mouse who is eating grass, so maybe they go down to a secondary consumer at that point. Or maybe they've eaten a snake who's eaten a mouse who's eaten grass. So then they go up higher on the food chain. But animals who are carnivores are going to be at the top, whereas our herbivores and our omnivores are lower down. So what I want to do now is I want you guys to meet a real-life decomposer. Remember, decomposers are animals who break down dead things on a smaller scale. Now this is an animal that I really like teaching about because it's an animal that most people don't like. When they see these animals, they squeal and run away. Nobody ever runs and wants to cuddle one of these, but they're actually pretty neat little creatures. What I have here are cockroaches. So there are over 4,500 different types of cockroaches in the world. Now cockroaches are actually really good to have around. In the United States, there's only 4 types that are the pest cockroaches that you don't want in your home. Those 4 types are the American, the German, the Oriental, and the Australian. But those 4 out of hundreds and thousands of cockroaches are the ones that are bad. That means all the other ones are good. These are Madagascar hissing cockroaches, and they are found in Madagascar, which is off of Africa, over on the other side of the world. And they live in tropical and rainforest areas there. Now, these guys are very important in the forest and the rainforest ecosystems because they eat the dead and decaying plants. Plants are very important to humans. 1, because they're the bottom of the food chain. 2, because they provide us oxygen, as well as food, medicine, all sorts of differing things. So if we have animals like cockroaches around who eat the dead and decaying plants, that means that provides room for new plants to grow. So we need our scavengers and our decomposers around because they help keep Earth clean, they keep it healthy and free of disease, and they provide room for new plants and animals to thrive and to flourish. Now these cockroaches are actually pretty cool. They're called hissing cockroaches because they do this characteristic hissing sound. Now when we hiss as humans, we use our tongue and our lips and our mouth to hiss. But cockroaches, they don't use their mouths to hiss, at least not the hissing cockroaches. They actually have overlapping holes out the sides of their body. These are called spiracles, and that is what they use to push air out of, and that is what makes the hissing sound. Now when they hiss, it can only be heard from about a foot or 2 away. It's not very loud. But these cockroaches live in colonies of hundreds of cockroaches. So when they all hiss by blowing air out the spiracles, it sounds like a bigger predator hissing, or a beehive or a wasp colony. And so most of the time predators don't want to mess with something that sounds really scary. But these guys are actually completely harmless. They can't hurt you at all. They are going to just be eating plants. Now, one interesting thing about this species is that you can tell if it's a male or a female just by looking at the top part of its body. What I have here, this one is a male, and we can tell because he's got these little horn-like structures on the top of his exoskeleton right there. Those are called pronotal horns, and only the males have them right there and right there. There's 2 big bumps. Now the reason they have those 2 bumps is because that is what they use to fight the other males. If you notice here, I've got a female. you can see that she does not have those 2 bumps on her exoskeleton on the top. The males use those bumps and they fight each other and they hiss at each other, and whichever male becomes victorious gets to go on a date with the female. So you can always tell if it's a male or female cockroach just by looking at its head. So my friends, if you ever find a cockroach or a bug in your house, please do not kill it. Just because that animal is there does not mean we want to hurt it. It is okay to call the zoo or to call a pest control person to see what they recommend, but bugs are important in the food chain. They are oftentimes going to be our first level or our second level of consumers. We need lots of animals on the bottom of the food chain to sustain smaller populations at the top. And you guys, here's the very important message for today. Humans, we are messing up our food chains. We are building roads, we are building houses, we are polluting, we are poaching. All of these things messes with the delicate balance that is a food chain. All of these animals and plants need to work together in harmony in order for this to work. If we come around and kill all of our bugs at the bottom of the food chain, while we might not like bugs, those are vital food sources for our lizards and for animals at the top. If we don't have any bugs, we don't have any lizards, which means we don't have any snakes, which means we don't have any mountain lions, okay? Or if we kill all the snakes, that means we don't have as many animals on the top. Oh, and now we have too many lizards and too many grasshoppers. So we need the right amount of each level in the food chain in order for these ecosystems to be in balance. So humans, we play a very important role in that. We need to make sure that we protect all of the animals, whether the ones that are charismatic and cute like a mountain lion or that are a little bit creepy crawly like a cockroach, because it is all important for energy transfer. So I know I just threw a lot at you today. There is so much to cover when we're talking about energy transfer. But the important takeaways are that energy cannot be created or destroyed. It comes from the sun, goes into plants, and then plants turn it into food that humans and all of the other consumers, all of the other animals can use to grow, reproduce, move, maintain their body temperature, stop themselves from getting injured. So we need to protect animals at every layer in order to protect ourselves. So if you are in 5th grade or feel like just doing a little bit of a challenge from what we learned about today, we do have a worksheet that talks all about the energy flow and the food chains and food webs like we just discussed. So there is a front and a back. All of the answers are on the bottom, but we also covered them in this video. And if you worked through this, please take a picture and put it in the comments. It will be up on the Facebook post and the zoo website soon as well. So please remember, my friends, that food chains and food webs are important to our world. We need to protect every animal because they are important to each other. I will now take time for some questions.
Vincia says, save the cockroaches.
Save the cockroaches! I love it. That's not a campaign you hear very often, but it's so true. In Madagascar, hissing cockroaches are one of the most fun types of cockroaches. They hiss, they can't hurt you, and they're just kind of a good starter cockroach. One interesting thing about cockroaches, just that I didn't get into, cockroaches are actually survivalists. They can survive some pretty extreme conditions. They can go up to a month without eating. They can go a week without drinking water, and they can even go a week without their heads. Now, this is not an experiment. Do not go and cut off cockroach heads, but they have very simple circulatory systems, and so the only reason they die after a week without their head is they've lost their mouth parts to drink and they dehydrate and pass away. So they can live in some pretty extreme conditions, which I think is actually really interesting.
Zach Esbel says, hi.
Zach what?
Asbel.
Oh, hey, Zach. How's it going, buddy? He's one of our camp kids.
And can these cockroaches fly?
No. This species does not, though, so this is one that's going to be living on the bottom of the forest floor, eating all of the dead plants.
Do we have a lesson scheduled about the opossums?
We already did the opossum. That was the first grade lesson, the very first one that we did. So you can go to the zoo's resource page or just go back, I think last week or the week before, it was the first grade lesson on adaptations. She was an excellent one. I want to say that was Friday the 27th of March. So you can kind of scroll back through the zoo's Facebook for that one. But I love opossums. I could talk for 45 minutes on them.
How do they survive?
The cockroaches?
The cockroaches. Yeah.
So they do have mouth parts. They do, consume their food like other types of animals. So they just don't have as complex of a system as we do, and so they do have to find their food and eat it, but they can go for longer periods of time without eating and without drinking. So it's the same things that we need, it's just not as intense. They don't have to eat as much as we do, and that partially is because they're cold-blooded, whereas warm-blooded animals like humans, we have higher metabolisms, and so we have to eat more often than cold-blooded animals who get their heat from the sun and the water and the earth around them. Okay, alrighty. Well, you guys, I know we just threw a lot of vocab at you, but there is so much to cover in 5th grade relating to food web and energy transfer. But really, all it boils down to is the fact that energy is constantly moving from plants to different types of consumers, and once those animals pass away, even to our smaller guys like our decomposers, our scavengers, through the soil and back. So remember, anytime you encounter an animal, we want to not hurt it. These animals are important to have around, they're important to each other, and we need healthy ecosystems and healthy food chains in order for humans to thrive as well. So tomorrow, we have a lesson for kindergartners. We're gonna be out back at the bigger part, another animal tomorrow, a bigger animal tomorrow, and we're gonna be talking all about how plants and animals change their environment, and we're gonna meet a pretty big mammal. So make sure to tune in tomorrow at 10 o'clock for the next lesson. Thanks so much.